Want to press? All right. We'll call the meeting of the Norwalk WPCA for November 21st to order at 5:31 p.m. There is a quorum present. Is there a motion to approve the meeting minutes of the WPCA held on October 17th?
So moved.
Mr. Igneri is the first. Any comments, questions, corrections? Anybody have anything to add, subtract, correct? No, I didn't see anything. It was pretty good to me. I don't hear anything, so all in favor, say aye, and please hold your hand up.
Aye.
Okay.
Aye.
Osterfine, Bovee, Manella, Constantine, Smith, Igneri. That passes unanimously. Thank you. Item number 3, authorize the Chief of Operations and Public Works to issue orders to contracts to Kovacs Construction in the amount not to exceed $250,000. Your motion to approve, authorize the chief. By Mrs. Smith. Mrs. Smith was first. Congratulations to Vanessa Valderas, who is now the permanent Chief of Operations and Public Works. Good luck to you. Is there any presentation from staff on this item?
Yes, Mr. Chairman. So this additional $250,000 in issue orders is for the Kovacs Pump Station project at Old Trolley Way, 5 Mile, Woodward Avenue, and Karen Drive. It's the total project cost is just over $4 million. The initial change order monies was in the amount of $200,000. We're at $170,000 currently that's been spent. And this $250,000 will cover us for the remainder of the project. We're about 50% of the way through the project. Some of the additional key change orders was we added Bell Island bypass vault. We'll actually have pictures of that later in the presentation. We also had some HVAC conflicts at a couple of the pump stations. So there's some change orders for that. We did at the treatment plant, we're doing scum tank instrumentation and electrical conduit. There was some piping that we didn't anticipate at Karen Drive pump station that we had to replace for the suction. It was old, wasn't part of the design. So for the most part, the change orders were not related to COVID or due to material pricing. There was minimal material price increases. I think it was about $15,000. It's more items that we're finding as we're doing the improvements at the pump stations, either some piping alignment issues or valves that we thought were fairly new, just weren't working properly. So that's where the monies have gone so far.
Anybody have any questions for Ralph? Comments? Okay, we'll call the question. All in favor? Aye. Osterfine, Bovee, Manella, Constantine, Smith, Igneri. Passes unanimously. Thank you. It is 5:34 and we have finished with the business portion of the meeting. Item number 4, contract operation reports.
Hello, can everyone hear me?
Yes.
Yeah, this is Matthew,
Matt.
Assistant Project Manager. I'm covering for John tonight. So I'll hit some highlights for the month of October. Veolia staff participated in the DPW and wastewater treatment facility open house held on Saturday, October 1st. The turnout was excellent and our staff enjoyed providing tours of the wastewater treatment facility as well as demonstrations of the collections equipment.
Hey, Matt, do you have any pictures? Because I can pull up the agenda just for your assistance, if that helps.
If you want, I mean, there's like 2 pictures on the executive summary.
Yep. Yeah, let me share the screen for everybody. And then that way, if everybody can see that, there's a couple of our pictures from the open house for DPW.
Yeah, so the picture on the left is in the office. You can see that we had different kinds of, and we have influent, primary effluent water, and I believe tap water on display to show you the differences in the treatment process. And on the right is our camera truck or CCTV truck, and that's our collections manager, Tim Sullivan, showing the public different instrumentations and telling them exactly what they do around the city. So that went very well. Unfortunately, I couldn't make it there, but I heard everything was great. So then Veolia, the collections team, we completed over 2.63 miles of TV inspection, and I'm sorry, 2.63 miles of TV inspection along with 2.32 miles of sewer cleaning. And they also completed 57 manhole inspections. The industrial pretreatment program, the IPP program, we completed 45 inspections, and we're on track to complete all inspections by the end of the year. We did have one regulatory issue in October, and that had to do with the sodium bisulfite pump lost communication with the SCADA system. And we do sample residual chlorine every 2 hours, so we did catch it right away. But it did create an instantaneous limit, which is exceedance. But as far as everything else was in compliance with the permits for the month of October. And that issue we had was corrected as soon as the operator ran the tests. He went out, inspected the pump, and got it running within that 2-hour window. The net DMR, MOR, and NAR reports were all submitted to CT Deep and the EPA in October. And a couple things I wanted to point out: our average daily flow for the month was 10.9 million gallons. Our 12-month average flow for the plant was 11.41. And then towards the middle of the page, we have effluent total nitrogen. Our total nitrogen is 487. And then if you want to go to the graph, Ralph.
Yeah.
I believe this is new, correct, Ralph?
That is correct.
So this is a new graph we started including in here. It's the rolling average since May 20 when we took over to now. This is the influent flow. You can see the design rate is 18 million gallons a day.
It's the red line at the top.
Correct. 90% of design flow is 16.2. 90% is the number that the DEP will and the EPA will start to make you plan for upgrades, right, Ralph? So that's why.
Correct. It's in our permit. If we hit this line, this green line, which is the 180-day moving average for flow, if that approaches at 16.2, the WPCA would have to submit a plan on either reducing flow to the treatment plant or look at future expansion at the treatment plant. So basically, just to explain the difference between the 16.2 and this 180-day moving average is our available capacity at the treatment plant before we have to do anything.
Right, and I'll point out the dip on the left towards 2020 was the summer of 2020. We had very, very, very long drought, and it was very, very dry. Some of the lowest flows in the industry people were seeing in the Northeast. But on average, for the past 12 months, like I said, we are at 11.41, so we're quite far away from those numbers. And then I think that was it. And then there's 3 PRFs. You need to share those, Ralph, or do you want me to just go over them?
You can just mention them.
Okay, let me just take 1 second to bring them up.
Actually, hey Matt, item 4C is the contract year 3 letter. Let's talk about that first. I have it on the screen.
Oh, you do? All right.
Let's see.
Sorry, guys. John just hidden. Okay. So the base service fee. You want to go over the CPI? Is this the
Yeah, Matt, I can explain this. I'm probably a little bit more knowledgeable on this, going over it with John. So basically, the contract with Veolia, there's 2 numbers that we look at. One is CPI adjustment, which was 7.3%, and the other is an employee cost index number, which was 3.63%. And the formula in the contract, when you do the math, it came out to 5.4%. And that's where this annual inflation adjustment number is. And they took the base service fee of just over 8 million, times it by that 1.054, got us to just under 8.5 million with an overall increase of 435,000.
So Ralph, this number will affect as of July 1st, correct? Is this going to be shown on the next operate?
No, this was actually July 1st of 2022. Sorry. The Veolia team and myself had been going back and forth, making sure all the numbers were correct. Specifically, the bulleted items down here, these were all conditions in the contract, and the team went to make sure all these numbers were bumped up according to the contract language. So we're presenting it a little bit late, but this is we're in contract year 3 as of July 1st of 2022, and this was the overall increase. Anybody has any questions?
Okay, so I'll jump into these are procurement review forms. Something we, any large projects, you've probably seen them before that we do in-house, we have to fill these out and we share them with Ralph. And so this 37,500, this was a backup Chicago pump for our Keeler Brook station. This pump, the Keeler Brook station has, I believe, two pumps, and they're critical. It's one of the critical stations that runs quite a bit. And their pumps are aging, and believe it or not, you can correct me if I'm wrong, Ralph, I believe we ordered this pump a year ago and we just got it.
Correct.
So now we are putting through the statement, because obviously they didn't bill us, so we got it. So now we're passing on the bill. So this is again a pump. Is it a spare? I believe it's a spare for Keeler Brook Pump Station.
It is a spare, but I think they're going to install this and
Correct.
Take out one of the other pumps and rehab them.
Refurb it. That's correct.
Yep.
Yep. And the second PRF is Aaron Associates septic tank instrumentation controls. Now what that is there was no scum removal in the plant, and one of our larger projects was doing a piping project last year and introducing scum removal to get scum out of our system again. So this is for the electronics that are inside the holding tank that's going to hold the scum before it's pumped. And that's what this PRF is for, this procurement review form. I believe that. And then the final one for the month on the procurement review form is the backup float systems. So at several pump stations, I believe this consists of 4, this particular one. I can't really make it out. Fox Run, Calf Pasture, Howard Ave, and Bell Island.
And Huckleberry.
Oh, and Huckleberry. So what it is if there is a failure of what we have electronic level controllers called transducers, and they run through a bunch of low voltage electronics. If anything goes wrong with those signals, the level controls will fail. And a lot of our pump stations didn't have a backup for that. So what these are is just an old school float. When the float lifts up, it turns on, and when it goes down, it turns off. A little more intricate than that, but it's a backup to the current flow controls in those systems. And the plan is to do a few a year. So in the future, you will see more costs contributing to the backup float systems as we do all the stations that didn't have them. I believe, was it 16 stations needing them overall, Ralph?
Yeah, I think we have 16 installed now. So we have a total of 22 wastewater pump stations. So we've targeted all the large pump stations that have this extra redundancy.
Correct.
And the whole intent is to avoid a sewage spill either into onto the road or into somebody's house or business.
Correct, because we will get a notification that they failed, but there's response times and everything, and these backup floats will prevent any of the, like Ralph said, any spills. I believe that is all we have for contract ops, unless anyone has any questions.
Yeah, a couple of questions. Are those pumps interchangeable between stations? You said we're having a backup pump installed in one of the.
So
stations.
most of our stations are sized uniquely. So we do generally use one pump manufacturer, except for this. This is one of the few stations we have Chicago pump. Our typical pump vendor is Flight. So the answer is no. This one would only work in this particular station. It is one of the older stations. So this is it's actually what we call a drive shaft pump, where the motor's upstairs, a long drive shaft goes downstairs to the rest of the pump which is the impeller and the volute. The
Gotcha.
problem we faced when we came here, when we took over, and just in general, a lot of the pumps, either if there were spares, they had to get redone, or some stations didn't have spares. So Ralph and our team have worked together to, take the inventory of all these pumps and make sure we have a spare for every single pump station. So if there is a failure, we can get up and running in as little time as possible.
Gotcha.
And Matt, just to add a little bit onto what you just said, every pump station has redundancy installed at the station, but we also like to have a pump on the shelf. So there are like 5 or 6 stations that have this equivalent like spare pump. So we don't have to have 5 or 6 for those. We have 1 or 2 that'll work. They're sized. The pump is sized to handle the same total dynamic head, which is basically an engineering design for that station. So they're all very similar in pumping capacity, but for most of the stations, we actually have a unique on the shelf pump for that pump station, besides the 2 or 3 pumps at the station.
And to add to that, your typical design in a pump station would be one, you have 2, it's designed for 2 pumps. One of those pumps that's there is designed to be a lag pump or a redundant pump. And then as triple security, we have one on the shelf. That's
Right.
kind of standard practice. Some of our older stations that are due for upgrades will maybe using both pumps to keep up due to expansion and things like that. But the standard practice is to have a redundant pump already there on site installed, and then one on the shelf. So that's what we're going for.
Gotcha. Thank you.
Oh.
Does that do it for D?
Any other questions for Veolia? Otherwise, we'll move on to item 5, reports.
Thank you, everybody.
Thank you, Matt. Item 5A is our typical fiscal year 22-23 munis report, revenues and expenditures. I won't go into any detail, but if anybody has any questions, please let me know. Item 5B, discussion on WPCF facility plan update. The team has a wet weather meeting scheduled for December 1st. It's a workshop with Arcadis. As you know, we're in the process of preparing the facility plan update. It's due to the state by June 30th of 2023. The other thing to note, we had submitted a Clean Water Fund application for grants from the state for 55% grant. And that's actually been moving along. That's about $260,000 that the WPCA is going to receive through this process. So we just got an email a couple of days ago from the state requesting the WPCA chairman to sign off on the agreement. Plus, there's some other documents that we have to provide. But like I said, we're moving in the right direction on that, receiving that grant. So we're very excited. Item 5C, what we're trying to do, instead of just talking about the WPCA capital improvement projects, we're looking to show everybody photos. So that being said, at the treatment plant, the aeration tanks, electrical infrastructure project improvements is complete. The main task was the steel support system that you can see going in between the 2 aeration tanks. This is carrying both higher voltage and low voltage for our pumps and motors, along with our SCADA programming. So there's a lot of controls out there on these tanks that there's new conduit, new wiring for, and then this also gives us a building block as we make improvements over the future years, that new conduit and electrical can be run on the same structure system. That way, the whole purpose was to move it out from below the grates. Used to be below the grates, and what would happen, water would find a way into the conduit and create shortages or electrical problems. In addition to this, we added LED lighting, so operators at night, they can turn on the switch, walk down. They have a lot more lighting to see what they're doing, grabbing samples or monitoring the tanks. This is all outside the solids handling building where MCC is actually located inside. Everything is new from the building out. So you can see the control, the the boxes or the wires coming in from the out from inside are split and then running out out to each of the tanks. So this was just over $1 million project. It was actually completed a little bit earlier than we anticipated, even with some of the delays from COVID. So we were very happy. And right now we're just doing a few punch list items. The second project we have going on in collection system is our Wall Street to Knight Street relocation project. And what we're doing here is we have a 30-inch oval pipe that goes underneath 2 Knight Street. And we're trying to, this project consists of moving it from underneath the building and getting it to a point around the structure. In order to do that, we actually have to put our pipe through what you're seeing here is a 77 by 122-inch storm pipe. So right now, this bluish pipe cutting through is our new sanitary sewer 30-inch. And this is the old storm pipe that's active. What we're doing, once this pipe is done, we're actually making a box around it because the whole intent is not to lose the pipe capacity for the storm flow flowing through this large diameter pipe. When it gets to where we're crossing, it's going to expand into a larger chamber and then back into the pipe. So that way we can maintain, I think it's like 940 CFS in that pipe for future conveyance. We have a couple pictures. You can see it's all the geotech. It's where all the expenses, and right now the rebar, this rebar in here, this is where the chamber is going to be. So once we're done and pour the walls, we're going to open up this pipe. Everything will be sloped, so it allows the stormwater to actually flow underneath our new sanitary pipe. And we have secondary containment, so that way we don't have any concerns about if the 30-inch pipe, you can see the blue pipe, if that was to fail or leak, where it'd be leaking into the storm, we have secondary containment already designed. So this project is about 2.2 million, and we're anticipating construction to be completed March, April timeframe of 2023. The next project is our Bell Island pump station improvements. Oh, sorry, there's some misprint here. What we end up doing again, we're always trying to look to reduce risk at our pump stations and at our facility. So what we have here in this upper left picture, that's the force main. It's an 8-inch asbestos cement pipe. And what a pump station does is flow flows by gravity from the local neighborhood to a pump station, and then the pumps pressurize a pipe and convey it up to a point farther away to a high point where it can flow then by gravity to the treatment plant. So if we were to have a failure or a problem at the pump station, we'd end up having to bring in tanker trucks to continue to convey sewage, so not to back up in people's homes or spill out onto the ground. Or the other option is to bring in a Godwin pump, but then you can suck from the gravity line going into the pump station or the wet well itself. But now you have to run a flexible pipe or hard piping on the surface to wherever you need to pump to. And for Bell Island, it actually pumps to Gold Road and Pine Point Road, which I want to say is like 1,400 feet away. But when you run piping on the surface, you're now blocking driveways, roads. You're creating a public nuisance. So what we ended up doing was we cut out a section of the force main, and we installed this vault with valves. And here you can see in this picture, we're connecting it upstream and downstream. And what this does or allows us to do is, in an emergency, we can come in with a bypass pump. We take the suction hose and install that into a gravity manhole, which is adjacent to this vault, to suck sewage from. And the discharge from the pump will connect into this bypass connection, which I have my cursor on. And then all we have to do is open and close valves. And now we're using the pipe that's in the ground to convey sewage from Bell Island area with minimizing impact to the residents. So once we installed the vault, and it's about a 12 by 12 foot vault, you can see here we have a hatch to access the valves, and here's the to operate the valves from the top from grade. Here's the 3 valve boxes, and then this is the restoration that was just completed a couple of weeks ago. This is what we're calling winter restoration. We are come the spring, we're going to go back and we will work with the Bell Island Association to restore it to before we disturb the area. I know the biggest thing is grading and getting grass planted again. So that'll take place in the spring. Next project I have on for discussion is our pump station, 5 Mile Old Trolleyway, Karen Drive and Woodward Avenue rehabilitation project. First couple pictures right here is from the 5 Mile pump station. We have a new service that it was just put in. And here's for a new generator, concrete pad. Not a lot of work's been taking place because the electrical has really slowed down the project. There's been a lot of back order. Some components like the generator is over a year out from when we ordered it early January this year. So, once it went through the engineer design, we went out to bid, the contractor submitted packages for review by the engineer to make sure it conformed to the design. Once we gave the okay, they put the purchase orders in January, and MCC's generators were still waiting for components to be delivered to the site. But as soon as that stuff does come, we'll be ready to go. All the mechanical piping, new pumps, all that has been received and it's stored right now in the pump station. Here's Old Trolleyway pump station, and there we did the same thing. This is the Kovacs contractors adding piping to add a bypass connection. So in this case, the valves are inside the pump station, the connection's on the outside. So what we would end up doing is tying the discharge line from a Godwin pump, emergency pump, into this flange, and then opening up valves inside the pump station will allow us to utilize the conduit in the road, the pipe in the road to convey sewage. Karen Drive pump station, more HVAC we're adding, electrical heaters, LED lighting. This is some of the work that's been going on. And then again, Woodward Avenue pump station, a lot of HVAC, LED lighting. We also have the bypass piping and new bypass connection outside the building, same as Old Trolleyway that we've installed. And then the last project is our SCADA upgrade phase 3. And I shared a couple screenshots. So this first screenshot is what the operator sees on their overview screen, which is just basically showing the whole treatment plant and various different levels or pumps on, DO levels, flow going through the facility. And then all these little tabs down here to get in, zoom into a process at the treatment plant, you would click that and it would bring you into like preliminary treatment, aerated grit, aeration tanks, aeration blowers, and that would give us a lot more detail. So some of the things that we've done recently, we've enhanced the system. Here's our plant water pump. So we're recycling treated wastewater, which now we call effluent, before it being discharged out to the sound. We're recycling it at just over 1,000 gallons a minute. And as you can see here, we actually pump B and pump C is red because those are online. Pump A and D are green because they're on standby. And what we're doing is we're pressurizing our plant water, and we use that for hosing down throughout the facility. We have sprays going on at the aeration tanks to help with the process. So that's what that screen gives us more information to know pumps are operating. If there's an alarm, we'll get an alarm. It gives us the pressure rate, the flow rate, so we have more eyes. So it's monitoring the system for us. The picture to the right, this is something that is really useful for the operators. What it does is it gives us a picture of all 22 wastewater pump stations and 3 stormwater pump stations. It's by name in this column, And then pumps, we either have 2, 3, or even 4 pumps at the station. Red means on, green means ready for standby. This yellow that you see, it's pulling the data from that station. So every 2-3 minutes, it's a radio system, and it's pulling the live data, the current data from each station. And then we have a generator column, tells us if the generator is on or ready for standby. This current level means it's the depth of the wet well level. So we know what if we have a concern. If this level or the pumps aren't turning on and we have an alarm, we can monitor this level. And we know if we're going to have a potential sewage spill based on this column is our critical level where we have that potential. So as long as the current level stays below the overflow level, we're good. But this gives the operators direction. If we have 1 or 2 stations that have a problem, they can direct crews which station to get to first based on live monitoring. And then some stations, we do have flow meters, and that's what this column provides, the flow rate at the station. And then the last piece is down here. This is monitoring across the river from the treatment plant. This is Ann Street. We're always monitoring the level in the chamber. We're at 1.2 feet. We know at 9.25 feet, the siphon, there's an emergency overflow that we could discharge out of potentially. So we're always monitoring to try to avoid that unless it's it's an act of God storm where we don't have much control. And then we also discharge flow. This is the flow coming in from the west side through the siphon underneath the river coming to the treatment plant. So that's it with the projects. Does anybody have any questions?
Thank you. Good background.
Yep. And we'll try to do this now going forward to give pictures versus going and just talking.
I like the pictures.
Yes, that's why I figured.
So do I.
Very helpful. Thank you.
What could you possibly do, Ralph, at the Ann Street siphon if the level starts coming up and the storm's not too bad, but it gets, I don't know, it sounded like you monitor it. What could you possibly do?
Good question, Darren, Mr. Chairman. Here's the answer. So down here, we have gates. We have a 30-inch and we have a 42-inch. So there's actually twin siphon barrels.
Okay.
So in SCADA, we have a program, an SOP, that the
Open up the
42-inch is closed, 100% closed, or zero. It's at 0% open, and the 30-inch is always at 100%. If in a rain event, this level starts to go up and we get to, I think it's 5 feet or 6 feet, this 42-inch gate will start to open. And it'll open in increments of like 25%. So before, I think it's at 8 feet is the setting. So we're well before we hit 9.25, this 42-inch gate will be 100% open at 8 feet. And now we're maximizing flow to the treatment plant.
Got it.
So that's basically, we're doing as much as we can to allow flow to the treatment plant. And what's also happening at the facility at the headworks, we have 6 main lift pumps. As flow increases to the plant, you're going to you go from 2 pumps to 4 pumps to ultimately 6 pumps running at 100%, which is pushing around 100 million gallons a day of peak flow through the facility. So we'll be maximizing our facility. So during Ida, we had 6 main lift pumps on at 100% to try to push as much flow through the treatment plant as possible.
Thank you. Wow.
Very good.
I guess you keep it closed so that the siphons operate better under low flows.
So there's a couple of reasons why. Because one of the things that we're trying to do is utilize our large interceptors for storage, because we also have outfall 002 at the treatment plant. And our goal is we don't want to discharge out of outfall 002 unless we have to. So outfall 001, we can push 30. We have to push 30 MGD through full treatment before outfall 002 can discharge. So what we're trying to do is we're backing up the system a little bit to utilize our
Okay.
storage capacity. But when we get to 5 feet or 6 feet, we're already around 30 MGD or very close to it. So when we start opening up that secondary gate, that 42-inch gate, we're now allowing more flow to the treatment plant, and the likelihood of having a discharge out of outfall 002 increases. It's a permitted outfall, so we're allowed. So that's, again, we're trying to minimize outfall 2 discharges by using our storage capacity, but we're trying to avoid Ann Street overflow discharge at all costs as well. So it's all programmed in SCADA, and it really comes down to the intensity of the storm and, to what level of storm intensity, and is it an act of God storm? Like, similar to Ida.
Thanks, Ralph.
Thank you.
All right. And then sewer use bills and appeals to date, there hasn't been any adjustments since last month. We're still at $39,341. And then the last item is information copy. It's a Wright Pierce task order number 14. It's just providing miscellaneous assistance with pump stations and at the treatment plant related to pumps. And this is an amount of $65,000. So this isn't a new contract. This was monies that was already, we entered a contract that was approved by the board, and we're just tying it or linking it to a task order with Wright Pierce.
That's it. Any questions for staff? No questions for staff. Any questions about anything on the agenda or not on the agenda? No. Okay, it is 6:08. Is there a motion to adjourn?
Everybody.
Motion
Mr.
to
Igneri.
adjourn.
Mr. Igneri raised his hand first. Okay, all in favor? Aye, that's unanimous. I'm not gonna call it off. Thanks, everybody, for showing
All
up.
right,
Good quorum, good business done. Good
Thank
presentation.
happy
you.
Thanksgiving.
Happy Thanksgiving.
Happy Thanksgiving.
Thanksgiving all.
Thank you, and happy
Enjoy the
Thanksgiving,
weekend.
everyone.
Thank you. Have a happy Thanksgiving.
Yes, happy holidays to everyone. I guess we'll see you on the 19th. And as I was congratulating Vanessa on her permanent appointment, my boss said Gentile overheard me and came in, and he wishes to express his congratulations also.
Thank you. Yeah, tell him that I say hello.
I will. I'll tell him in the morning. He's gone for the day, but thanks. Everybody good?
Yeah.
That's good.
Thank you.
Thank you.
Bye-bye.